Welcome to Advanced Higher Maths. You can find this course structure on the Melbourne website, and wherever possible we'll try to follow this plan. However, we may deviate from the order depending how long we're working online. Some may be easier for you to cope with online and others may be easier to put up than others online as well. So the order may change. But regardless of the order of the topics, with hard work and determination, you shall definitely gain brilliant skills to go to university. I'm confident if you give it your all, you shall enjoy the experience and a few challenges along the way. Topics that we aim to get through this term involve differentiation, the Euclidean algorithms, brand new for you, part of numerical analysis, on to Gaussian elimination, which extends towards matrices. And then hopefully we will be back at school, but if not, then we may consider binomial expansion, however that may be one for at school. Okay. Welcome to your first topic then. We are going to look at differentiation first, and before we go through any new things, we're going to make sure we go back to basics and check and refresh your skills. You should be comfortable with these, but some of them may make you think a little. I'm going to give you 7 tasks. Now these might take way over half an hour for you. It just depends how confident and you feel about your skills. Okay, I've put a prompt for question 6 and 7 because they are a lot trickier, but for the first 5 it is just checking your basic skills. The first 5, you can see here, you can either pause now and try the questions, or you can open the PDF and try them at the side, okay, because I'm going to go through the answers in a moment, but I'm going to ask you to pause or stop. Question 6 is the equation of a tangent. Do you remember how to cope with that? And it's not the easiest of functions to start with. And then question 7 is a curve sketching question. So you'll find that I had to change the size of that there, sorry. Okay, then you'll find that I've put down there, find the axes, the roots, find the stationary point, your y coordinates and your nature. And the extremes mean what happened at the ends. So if you could try those just now, you can either pause or close this. The PDF's attached so that you don't have to listen to my voice. And if you want, you can check your answers in the PDF, but I'm going to go through them now. So how did you get on? Okay, don't go to the answers unless you've already tried them and you're just checking them out now. Okay, here we go. So let's see. So the first one, what have we got? We've got x to the minus 2, bring the minus 2 to the front, take 1 off the power. That's fine. You could take it to be positive indices as well, take it a little bit further and express it like that. If it's just to the x, then it's just checking that you remember that you get a third out. What happens here? You have to set it up first. So remember that you have to put x squared over each one, divide both by x squared, then you get 3x, and you get x to the minus 2. Remember always to bring it upstairs 2. Now we can differentiate, that's okay. And then lastly, remember you've got the minus 10 there. Don't write plus minus, always write minus, and then you can express it as a positive index as well. Sign doesn't change sign, so sign goes to cos, but remember the chain rule with the 2, that comes out, and then bring the 2 to the front. And this one here, we have to bring it up, so it's to the power minus a half, minus a half. Now look at the notation there, it doesn't matter, it might look odd, but it doesn't matter what they give us, we should be able to differentiate, so I'll call it y dashed x. And then the minus half will come to the front. Remember, minus a half minus 1 is the same as minus a half minus 2 halves, so my power goes to minus 3 halves, and the chain rule comes out. The 3 times that is minus 3 halves. If you want to keep it as that, it's acceptable, but I know that you're better than that, so you can keep the minus 3 upstairs and then bring the power downstairs, make it positive, and even put it back into third form. I'm hoping you got on okay with those. Right, let's go to question 6. I've not put animations in. Have you realised that you need to find the y coordinates? So if x is 1, you can just slot it in. Have you expanded so that you can then differentiate, and then known that the gradient is the same as the derivative? So when you substitute in 1, you get the gradient of 11, and then found your equation. Question 7 I'll just hide it. Okay, so the first thing is axes. So put x as 0 in. If you put x as 0 in, you get 0 in. So there's one of your coordinates. If you want the roots, so the roots mean that we want to find out where it cuts the axis. So it's got no height, so set the y equal to 0. Then we can factorise, pull out x squared, solve, and you get x equals 0, and you get out x equals minus 3. Now, actually, from your functions, you should know that x squared, when you have that, you get it out twice. What that means is it rests on the axis, but we'll look at that when we get the graph. The next thing is Arson's stationary points. How do you find stationary points? We take the function and we differentiate it. So differentiate, set equal to 0. We can pull out 3x. Then you get x is 0 and x is minus 2. So you've got two stationary points. What's next? ARS, we've got arson. Y is next, the y coordinates. So if x was 0, we've already found that away up at the start there. We've got 0, 0, and then if you put minus 2 into the original function, we get out 4, so we've got two stationary points. But what's the nature? The nature, as it's tending to minus 2 and then tending beyond that. The nature, if I just separate it, now everybody's had a different teacher, so it's just to remind you that if you do have your derivative here, you can just substitute in right away. There's no issue with that. But if it's complicated, you can split that. So the 3x and the x plus 2 I've done here. So if I put in a negative, 3x will be negative, minus 2 will be negative. Let's say that's minus 1, it will be negative. Put 0 in, you get 0 out. Put anything positive in, you get positive. What about x plus 2? If you put, let's say, minus 3 in, it will be negative. Put minus 2 in, you get 0. Put in minus 1, you'll get positive, and then after that you get positive. So if you've not seen that style before, what I've done is split up the stationary points and then multiply it to find the total sign. So that means that when you multiply minus and minus, it's an increasing function before that. As it's approaching minus 2, it's positive, going upwards. And then you have a stationary point at minus 2, and then between minus 2 and 0, it's going downhill. It's a decreasing function at that point. And then we have another stationary point, and then beyond is positive, going upwards. So that means that we've got a positive slope, stationary. You've got a maximum at minus 2 then, and in fact it's at minus 2, 4, and a minimum. And then you can draw the extremes. Just now for us is just extending it so that it's not just finishing at the stationary point, okay? But at a later point, we'll be looking at what's called the extremes and looking at things called asymptotes and looking at what happens to it. So you've got fancy notation there that's in the Scholar book. However, you're just, for this purpose, drawing it extended a little bit. Okay, in the Scholar example in the textbook, you'll also see that they use pluses and minuses here instead, and they use two separate tables in the example. It doesn't matter, you do whatever is nicer for you. You won't have to go up and down like that in the PDF. The whole thing should appear in the one page. Right, okay, your next task. Now that you've been warmed up, now you're going to try these questions here, these 3 questions, and then you can check your answers. So the answers are in the next slide. So again, don't look until you've tried. So after 3, stop or pause. 1, 2, 3. Now I'm going to go through your answers. You can check your answers. You can pause it, check your answers. I'm not talking through every step of those. You can check your answers. You can pause and stop. I'm not going to talk through every part of that. And then you can check your answers. Again, you can use the PDF just to have a look. Okay? Right. All of this can be found, including the revision questions, from page 44 to 47. If you open the PDF Unit 1 Scholar, I've only uploaded the first one just now because you don't need the others, but eventually you'll see Unit 1, Unit 2, Unit 3. Okay, the answer pages are at the very back. So you'll see on the right hand there will be a kind of contents, and the answer pages are at the bottom. So if you want to try the questions and not listen to me, you can use that as well. So if you want to check all your answers, go to page 243 on the PDF. Okay. first part done.